Hello class. Today I will be going over our week 4 summary for this week, and I will be using a Prezi to display the information that I'm about to say. So let's get started. So Tuesday, David showed us a blanket experiment, which we all went to the center of the room and held out a blanket and held it tightly, and he placed a bowling ball on it, along with a golf ball, I believe, to simulate the attraction of charges to one another. And the flip side could have been done for the repulsion if he would have flipped over the blanket again, if you saw it from the bottom and you tried to roll a golf ball, it would be repelled in the certain directions. So I thought that was really cool and a great experiment, a visual experiment and a hands-on experiment. So Tuesday we also used PhET, which is the computer modeling for charges and electric fields, and we placed certain positive charges around, and we simulated what the probe would do if it would go away or it would go towards. And first we went through on our boards, and using vector addition we tried to predict what was going to happen, and then we plugged it into the PhET simulation to see how our predictions panned out. At first I was a little confused with the vector addition, but eventually I saw that you draw arrows in towards the direction of the positive charge to see that it's attracted, or away if it's negative, and then you sum them up for the vector addition portion. So I thought that was a really cool experiment as well. Also, a really cool thing happened this week where Einstein proved a theory over 100 years ago, and when two black holes are combined, they make a large pulse in the form of gravitational waves. And I thought that was really cool, and it was a really cool video on it that David showed us as well. So also we used Arduinos because David told us we were going to have to do a presentation, and each group had 2 Arduinos to look at in more detail and make a presentation on it. We had one that was using a photoresistor and a noisemaker, and it was quite loud, which I'll show you a video in a little bit. But this photoresistor, if you hold your hand over it, it detects how far away your hand is, and it makes a pitch depending on that. And this circuit wasn't too bad to create. So here's the video. Let's see if I can. As you can hear, as our hand comes closer. So as you can see, it's very loud and kind of annoying, but it was pretty cool nevertheless. So like I said, the presentation, this is the overview of the presentation that we have to include. It has to be a screencast, like the one that I'm presenting now. An overview of 1 minute, hardware of about 2 minutes, software, showing the build, the extensions, which is things that you can go further with inside the circuit itself. Special devices, each different project had a special device attached to it. Ours was the photoresistor on the last one, which you saw, and then we had another one, number 11, which was the use of an LCD screen. And then of course a conclusion to wrap up the thoughts. And on Tuesday we went through this whole circuit, and it still wasn't working correctly. As you can see, there's a lot of wires, and they're placed all over the place, and it's really hard to diagnose when the circuit isn't organized. So we took a picture of it, and as you can see, the LCD does not display any information. So we decided to come back to it on Thursday and see if we can get it working then. Also, we worked on whiteboards to see where a magnetic field is 0. As you can see, between this positive and this positive, it's going to be 0 right or it's going to be neutral right in between. Right here, between the positive and negative, there's not going to be one. Even if it's infinitely far away, if you place a sensor, it's still going to be attracted to one of the charges either way. And as you can see from the other ones, we did a couple more, and then we plugged them into the FET to see how right we were, and so on and so forth. Okay. On Thursday, we also did whiteboards with a charged rod. So I personally had D over here, and the experiment was when both of them are charged, and then a negatively charged rod or a positively charged rod is placed near the two touching balls, what will happen when the rod is taken away. So as you can see, the negative charges flow to the positive because it wants to be closer to it. So these ones become ultimately positively charged, positively charged. And I wrote here, both are positively charged. The negative charges leave when the rod is attached and pulled away. And Arduino part 2. So on Thursday, thankfully, we got our Arduino to work properly. This is our LCD screen, and it says ask the crystal ball. And then when this bypass switch right here is unplugged and plugged back in, it gives you your fortune, per se. The code for this one was a little pretty hefty, but it was everything needed to be there. So there's one particular thing that I found interesting was on this line, you have to actually tell the LCD panel or how much it can display. So it can display 16 characters on the first line, 16 characters on the second line, and so 32 characters in all. And you actually have to type out ask on one line, and then tell it to move the cursor to the second line to say the crystal ball. So you end up with 2 lines of code. And as you can see right here, this part was a little hard to get working. I think that might have been our issue with the first time, just organization and not keeping track of things. But this part right here, there's a wire attached to one of these prongs, and then it's plugged into the breadboard because without it, it wouldn't be able to fit. So we actually had to wire it and wrap it in a sort of odd way. But in the end, it worked, and couldn't be happier. So, in conclusion, this week we learned about the use of charges, or not the use of charges, but different visualizations of charges using the FET simulation and using the blanket experiment that David showed us on Tuesday. And we also work extensively with Arduino programs, looking at them in more detail and creating screencasts for them. And also there was listed on Canvas, there was a video called Waiting for Superman, which was interesting. I don't want to say it was nice because it was pretty sad, but it was taking a deeper look into our education systems and following the lives of a few young kids and their struggles and things they have to overcome to make it through the education system, and the whole idea of the lottery system. I thought that was really, really cool that David showed us that, but it was sad at the same time. So yeah, this week was a very long, extensive week, and a very educational week, and a historical week for the black holes and Einstein's theory. So yeah, this is my week 4 summary. My name is Nicholas Gibson, and I hope you enjoyed.